In this video, we're going to take a look at addition polymerisation. So on the board, I've got a very simplified representation of an alkene. So you can see the carbon-carbon double bond, and then obviously across these two carbons, you'd have two atoms or groups attached on this carbon and two atoms or groups on the other carbon. And what we're going to do is imagine it was exposed to a high temperature, a high pressure and a catalyst. So what happens under these conditions is the double bond is broken. Now the actual mechanism of what happens is quite complex, but for the purpose of the A-level exam, all we need to appreciate is that under these conditions of high temperature, high pressure and catalyst, the double bond breaks. So you can see on the right hand side now, we've got a saturated molecule. So we've got a carbon-carbon single bond now, where there was unsaturation here with the carbon-carbon double bond. On this carbon, we've got space to add something, and on this end of this bond here, we've got some space to add something else. So let's take three of these generic alkene molecules and expose them to a high temperature, high pressure and a catalyst. The double bonds break, and hopefully you can appreciate what can happen. We've got some space here, we've got some space here, so we can connect those two carbons like that, and we can do the same there. So basically what we do is we start adding those individual alkene molecules. Once the double bonds are broken, we can start adding them together. So we'll have a look now at how to represent that in terms of a chemical equation. So we've got our unsaturated starting molecule, and this is known as the monomer. So this was that alkene that I showed on the board at the start, and you'll notice this little n, this lowercase n here. You wouldn't just have three of those like I did on the previous shot. You would have typically between 2,000 and 20,000 of those. Under these conditions of high temperature, high pressure and catalyst, remember the double bond breaks, and all of those individual molecules, once their double bonds have broken, they can all add together. And so you have this incredibly long, so 20,000, that's pretty long, incredibly long saturated chain, which we call a polymer. And poly just means many. So you can see the N now has gone after this bracket, because effectively this here just keeps repeating and repeating and repeating. The end bonds, it's really, really important that you show these end bonds, and they must go through the bracket. They mustn't finish before the bracket. So in the exam, you must make sure that this goes continuous through the bracket, and the same on the other side. Because what you're saying there is that this continues, it's a continuous chain. And you may have noticed that's why I've done that with the A and the N at the end there. So we'll look at a specific example now. So I've got my three alkenes back, and they're all identical. These monomers are identical, and the green represents a chlorine atom, the white represent hydrogen, and the black obviously represents carbon. So these monomers are called chloroethene. Chloroethene, chloroethene. So we're going to expose them to that high temperature, high pressure and catalyst, and what's going to happen, we're going to break these double bonds and then just add them together. So there they are joined together. You can see at the left hand side, if I just turn that around, you've got that hole there. So if I had a fourth monomer, I could break its double bond and add it here, and you can see this bond sticking out there. If I'd had a fifth monomer, I could have added it to there. So we've got the continuous chain now, and you can see how it repeats. So it repeats every there, there and there. So you can see the original monomer just repeats again and again and again. And then we've got it drawn up on the board now. So you can see I'm showing the continuation of the chain by the end bond here. So that's this bit here. And this bond here continues, shown by that bond there. So what's repeating? Well, it's obviously that bit there. So we've got 3 of these, and we call this the repeat unit. So in that length of polymer chain that I've drawn up on the whiteboard, we've got 3 repeat units shown. So you can see above we've got a chemical equation for what we've just demoed there. So we've got N moles of the monomer, chloroethene, high temperature, high pressure catalyst, double bonds broken, and the way we represent the polymer chain is we put the repeat unit, just one, in a bracket, and we make sure the end bonds are sticking through the bracket, and that N goes on the bottom right hand corner. And we'll just look at how to name them now. So the monomer for this one is called chloroethene, and the polymer is simply known as polychloroethene. So all you do is put the word poly in front of the monomer to make the polymer name. So chloroethene becomes polychloroethene. And just be careful when you're naming the polymer. Sometimes you might think that because you've created a saturated molecule, so this is saturated because we've lost the carbon-carbon double bond, should that not reflect that in its name and be called polychloroethane? Basically, this name just means many chloroethenes have been added together. So the ethene part stays. Now often chemicals have more than one name. The old name for chloroethene was vinyl chloride, and so the polymer that you form from this monomer would be called polyvinyl chloride, and we know that as PVC, and that name's still widely used today. But it's actually polychloroethene. So we'll look at a typical question now, and I'll share with you a top tip that my chemistry teacher gave me when I did my A-level chemistry. So we've got an alkene. So this alkene can be polymerized. Write the chemical equation for the reaction and draw a length of the polymer chain showing 3 repeat units. We're also going to have to name this, so think about the name for that as we go through. So I'll start with the top tip from my chemistry teacher. What he always told us to do was make your monomer look like an ethene molecule. So that doesn't really look like ethene, but we can make it look like ethene by drawing the carbon-carbon double bond, putting the 4 bonds, so 2 off each carbon, and then add the atoms or groups that are going to be on each of these carbons of the double bond. So that's that carbon and that carbon there. So we'll start with the left-hand one. What have we got on this carbon? We've got a hydrogen and we've got a CH3 group. What have we got on the right-hand carbon? We've also got a hydrogen and we've also got a CH3 group. And that's going to make our job so much easier when it comes to sort of visualizing what this polymer is going to look like. So to create the continuous polymer chain, all we need to do is break that double bond, put the end bond straight in so we don't forget, and then just put the atoms or groups back on. So we've got a CH3 there, an H there, a CH3 there, and an H there. And then the final thing we do, remember, there's not just one of these, there's thousands of them, so we represent that by a lowercase n, and we just put that in a bracket and put the n on like that. So there's the balanced chemical equation for the polymerization of this alkene. So we now need to do a length of the polymer chain showing 3 repeat units. So in the main backbone, we're going to need 2, 2, 2, so 6 carbons. So we'll draw them up first. 1, 2, 3, 4, 5, 6. Don't forget the end bonds, and then just put some empty bonds on. And then just fill up with the groups. So we've got CH3 there, H there, CH3 there, H there, and so on. So there it is there. And you'll notice that for the length of chain with these 3 repeat units in, we don't use a bracket. You only use the bracket to represent the repeat unit. So what's this polymer called? Well, the monomer is 1, 2, 3, 4 carbons long, so that's bute. Carbon-carbon double bond between the second and third carbon, so this is butene. And so the polymer would be called polybutene as well. One of the other things you have to be able to do is the exam might supply you with a length of polymer chain. So we've got a polymer chain here called acrylonitrile. The reason this Duplo bus is here is because one of the polymers used to make things like Duplo and Lego is acrylonitrile. So this is the chain here, and what you have to be able to do is work out what the original monomer was to make that. So let's have a look at some repeat units. How many repeat units have we got here? Well, you can see that we're getting repeats there, there, there. Okay, so we've got 1, 2, 3, 4 repeat units. So once you've identified the repeat units, visualize what one of them would look like on its own, or sketch it in pencil or something on the corner of your paper. So I'll draw it up here. So we've got that CN there, and then the rest are H's. And then all we need to do is reverse what we did before. So when we had the monomer, we broke the double bond and put these end bonds on. So we're going to do the opposite to that. It's easy on a whiteboard, so I just need to do that, that, and put the double bond back. So that is the monomer.